This is the third installment of the videos for Managerial Finance class on Chapter 6, Bonds. A common measure of short-term return on a bond is what's called the current yield. And here's how it's calculated. We divide the annual interest, these are dollar amounts, by the current market price of the bond. Now, the current yield is not just the yield to maturity at the present time. It actually is a specific, as you can see here, specific ratio you need to understand. The current yield might be of interest to a short-term investor because you see all it does is it characterizes the return on the bonds as solely related to the amount of interest you receive. It ignores any change in the value of the bond over the long term. And so for the applied materials bond that we just looked at, the current yield would be the $90 annual interest divided by the market price of $910. It's saying, maybe answering this question. It says, if I buy this bond, $910, and I hold it for 1 year and get that interest payment, and let's say that the price doesn't change any, what rate of return would I be earning? And the answer is you'd get $90 on a $910 investment, and you would earn a 9.9% return. And so it's really, let's say, a measure of short-term return and would not be of much use or interest to a long-term investor because the long-term investor is going to be more interested in the yield to maturity. Note that the current yield is lower than the YTM, which was 10.5%, because this bond is trading at a discount. In other words, if you buy the bond for $910, you do get those $45 payments, essentially $90 a year, interest payments, but you also get $1,000 at maturity, so an additional $90 that supplements your overall return on the bond. The current yield ignores that change in the value that will occur over the life of the bond as it nears maturity. Well, let's look at some important, what we call bond relationships. First of all, we talk about the relationship between changes in market interest rates and bond prices, or market values. The broad picture is this: as interest rates rise, bond values go down. And conversely, as interest rates go down, bond values go up. In other words, there is an inverse relationship between interest rates and bond prices, bond values. Secondly, the relationship between the coupon rate, the market rate, the par value, and the price. And again, I sympathize with the confusion here, but again, realize the coupon rate could also, a term like stated rate or contract rate could be used. For the market rate, you might talk about the yield to maturity, the market's required rate of return. Par value could be face value or future value even. And the price, of course, could be, market price, I suppose. There's not many variations for that. But here's the relationship you want to be aware of, the relationships. First of all, when a bond's coupon rate equals the market rate, that bond will trade at par. Its market value will equal par value. And we're going to look at an example in just a minute. If the bond's coupon rate is greater than the market rate, that bond's market value will be greater than par. In other words, if the bond is making interest payments greater than what the market demands, then the price of that bond will be bid up above par value, and that bond will be said to trade at a premium. And conversely, whenever a bond's coupon rate is less than the market rate, that bond's market value will be less than par, and those bonds are said to be trading at a discount to par. So there they are, stated together. Number 3, for a given change in interest rates, the value of long-term bonds will be more dramatically or drastically affected than the value of short-term bonds. This is the basis of what's called maturity risk, which is one of those elements in the risk premium from Chapter 10. This, by the way, this maturity risk is sometimes referred to as interest rate risk. Let's look at an example of how this can be demonstrated. Consider the case of two bonds, Bond A and Bond B, not their real names, that differ only in term to maturity. Notice they have 8% coupon rate. The market's required rate on these bonds is exactly 8%. The first bond, though, bond A, matures in 5 years, whereas bond B matures in 20 years. Now, keep in mind that means that bond A will make 10 semi-annual interest payments, bond B 40 semi-annual interest payments. Well, let's see how we value these. As you can see, if you crunch the numbers here, just make sure you understand how these are set up. But if you crunch the numbers, you'll find out that the present value of bond A is $1,000, and so is the present value of bond B. Now you might wonder, how is it that bond B, because it makes so many more interest payments than bond A, why isn't it worth more money? And the answer is because that $1,000, largely, see that $1,000 in bond A, you're going to get that in basically 5 years. But that $1,000 in bond B is going to take 20 years before you get that. So just imagine there's an offsetting. Although you get more interest payments with bond B, that $1,000 that you're receiving is much longer delayed than it is for bond A. Well, anyway, the notion or the idea you want to draw from this, or observation to make, is that as long as the coupon rate equals the market rate, a bond will trade at par regardless of the term to maturity. But let's see what happens when interest rates change. Let's say the market rate for this bond rises from 8% to 9%. And let's see how we value those bonds. Once again, make sure you're comfortable with this model. They're the interest payments. They haven't changed. The N hasn't changed. But you notice in both cases, I is 4.5%. That is the 9% divided by 2. And notice also that with that increase in interest rates, the values of both bonds go down. But in fact, the value of the long-term bond, bond B, goes down much further, doesn't it? Bond A's value dropped from 1,000 to 960. Bond B's value dropped from 1,000 down to 908. And you can see here, bond A's value fell by $40, about 4% from $1,000. Bond B's value fell by more than double that percentage, 9.2%. Now, what this shows is, and by the way, what will happen if the market rate of interest falls? I haven't shown the calculations here, but you could do that. Matter of fact, you would run through the calculations again, but use 3.5% as the discount rate, 7% divided by 2. If the market rate falls, say, to 7%, the bond values will rise, but the longer-term bonds will be more dramatically affected by the interest rate change. This greater variability of price for the longer-term bonds is basis for what we call maturity or interest rate risk. Long-term bond prices are more sensitive to changing interest rate levels than are short-term bond prices. I say here, be aware of the waving arm. If you were in class, you remember the example I gave was to kind of stand up and hold my arm out, and then I patted myself on the shoulder there near the end of my arm, and my arm joins my shoulder, and said, this is short term, my elbow is intermediate term, and out there in my fingers, that's long-term bonds. And then if I take my hand and move it up or down, you can see that the long-term bonds are going to vary more dramatically for a given interest rate change. That's what's demonstrated by the waving arm. And if interest rates go up, bond values will go down, and long-term bonds will go down by more than short-term bonds. Going back to the original position, with my arm straight out, if interest rates go down, bond values go up, and those long-term bonds will go up more than the short-term bonds were. In class, I drew two pictures there. At least I proposed two situations. You're a bond portfolio manager. Let's say you must be fully invested, which means, let's say, you've got to have 90 to 95% of your funds invested at any given time. If you think interest rates are going down, then bond values are going up, and for the most part, the long-term bonds are really going to go up a lot more than short-term. That's where you want your money. If you're confident interest rates are going down, you want your investments to be primarily in longer-term bonds. On the other hand, if you think interest rates are going up, then you know bond values are going down, and you would rather have your portfolio more in shorter term bonds rather than long term. Again, the situation I proposed is that you have to be fully invested at all times. That's, let's say, part of what's called the charter of the fund, restriction that's imposed. But anyway, that's what the waving, be aware of the waving arm means here. And that's all for these videos. I hope this helps you to take in some of this information. And of course, you can always free to email me and ask me questions.